We are getting to start a new unit today, Unit 7 on quadratics. Quadratics is going to be a new style of graph. So if you take a look at the pictures shown below, you will see that these are not straight line graphs. These are not linear functions that you're used to seeing. This is a new type of graph, and they are called quadratics. I'm highlighting the name located at the top of your notes. Quadratics are a unique shape graph. They are U-shaped, and we are going to be doing quite a few things with these graphs this semester. It's a big part of semester 2, and it does carry on into Algebra 2. So we're going to start by finding solutions to quadratics. So the definition to a solution is where it is located on the x-axis when the equation is set equal to 0. And we're going to do this in two different ways. One way is when we're already given a picture of a graph, and all we're going to do is look at the x-axis. The second way is when we're given an equation, and we have to do a little bit of work ourselves to set it equal to 0 and find those numbers. So let's delve into what solutions are. So a solution is a quadratic and where it is located on the x-axis, but it does have different names. So there's a list of names right here: roots, zeros, and x-intercepts. These are different ways that the same question can be asked for you to find where the graph crosses the x-axis. There's a little tool that we use. It is called ROXS, R-O-X-S, where R is for root, O is for zero, X is for x-intercept, and S is for solution. So if you're ever asked a question on a test and they ask for the root or they ask for the zero or the solution, all they're wanting you to find is the x-intercept. So let's start by looking at our first quadratic, and they want to know what is the solution to the quadratic when it's set equal to 0. And so that's just a real fancy way of saying, okay, let's go ahead and go to our x-axis. And let's find where that quadratic intersects that x-axis. And so you can see that it intersects the x-axis at one spot. So we're going to call this a one solution. We're going to write that solution as an ordered pair. So remember, ordered pair is a fancy way of saying the coordinate. You need to know the x number and the y number. And so you can see that this particular parabola, or quadratic, is intersecting at the origin 0, 0. Another way to write solutions is just to list the x. So I'm going to put that off to the side. List the x number. And so since there's only one x-intercept, or one solution, we're only going to list one number, and you want to know the number at its x spot. So it crosses the x-axis at 0. And then you're just going to put braces around it to say that, okay, there's only one solution, and there's only one solution when it touches x at 0. All right, let's take a look at the second quadratic. The question says, what are the zeros of x squared minus x minus 2 equals 0? So again, whenever you see that word zeros, you think of ROXS. 0 is on our list, and that's just another way of saying, okay, find the x-intercept. So you look at your x-axis, wherever it's at. You find the points of intersection. We call these x-intercepts. And so you can see that this one has two solutions because it crosses at two different locations on the x-axis. So because there's two solutions, you're going to have two different ordered pairs. We're going to label them x and y. And we're going to go in order from left to right. So on the left side, you can see it crosses the x at -1. You need to be sure to put that number in the x spot. And then on the right side, it crosses at 2. And because the definition of an x-intercept is where it intersects the x-axis, it stays on the x-axis, there's no up and down movement. That means your y-coordinate will be a 0. So our two solutions at order pairs are -1, 0, which is the left side, and then 2, 0, which is the right side. Or you can write it as a list of numbers. So remember, our list is just the x numbers, and those x numbers are -1 and 2. So we're going to say at -1 and 2 with some braces around it and the braces show that this is not an order pair. The braces say this is just a list of numbers, -1 and 2. And then if you look at the third quadratic here, I'm going to highlight that U shape. You can see that this U shape does not actually cross the x-axis. So that means something that we've talked about before, that this is a no solution. And so when they ask for solutions as ordered pairs, you have two options. One is to do the verbal no solution, where you actually write out the words. Or you can choose to use the symbol for no solution that we learned in first semester. So the first method of solving quadratics is by graphing. You look at those roots, zeros, x-intercept solutions by stilling the numbers of where it crosses the x-axis. Now we're going to switch to the second method of solving quadratics, which is by factoring, which is what we just tested. That's our snowflake. So we have to make sure, first step, that it is set equal to 0. So if you look at all the examples on this page, these are all set equal to 0. And so that's going to make it easier for us to do some work. If it's not set equal to 0, we have to do some maneuvers ourselves before we can continue going in the process. So let's look at those top 3 versus the bottom 3. These top 3 have parentheses, and the bottom 2, the last two, 5 and 6, they don't have parentheses. So when you have the parentheses set up like this, number 1, number 2, 3, and 4, that means it's already been factored for you. They already did that snowflake method for us. And so we get to skip some steps there. So you can see that we've already done step 1, it's set equal to 0. Step 2, it's already been factored. And so now we're going to do step 3. This part is kind of new to us. It says to set each factor equal to 0 and solve for x. So we're going to take factor number 1, x minus 4, and we're going to set it equal to 0, and we're going to solve it for x. So we're going to bring back those old school steps where we're trying to isolate the variable, get x by itself. X is our target, so we need to remove minus 4. In order to isolate, you need to do the opposite. Opposite of a minus 4 is to plus 4. And what you do to one side, you have to do to the other. So those opposites, -4 and +4, they will zero out, and your x gets dropped down, and now it's isolated, it's by itself, and you just need to simplify that right side. So 0 plus 4 becomes 4. And you're going to do the same thing to the second factor, x plus 3. And so remember, the factors are the parentheses. Each parentheses is its own factor. You're going to set it equal to 0, and then you're going to solve for x. So to get x isolated, to get x by itself, you need to remove a plus 3. So opposite of plus 3 is a minus 3. What you do to one side, you do to both sides. Opposites will zero out. Your x will drop down. And then simplify that right side, 0 minus 3. If you need to, then type it into Desmos. 0 minus 3 becomes -3. You're going to do the same for number 2, number 3, and number 4. So if you want to pause and try number 2 on your own and then come back and check, you are welcome to. I'm going to go ahead and look at number 2 and run through my steps. Step number 1 says it has to be set equal to 0. I can see that it's set equal to 0. We are good. Step number 2 says to factor. It's already been factored because it's already in that parentheses form. And so now we're going to do step 3, where we take each factor, starting with the first one, set it equal to 0, and solve for x. So on this one, you can see that there's an extra coefficient, which means we're going to have one extra step. We still need to cancel out or zero out that -1. Opposite of a -1 is a +1. What you do to one side, you do to both sides. Zero out your opposites. Drop down your 2x. Simplify that right side. 0 plus 1 is 1. Now, to completely isolate this x, remind yourself that a number in front with no plus or minus means multiply. And so we have to do the opposite of multiply, which is to divide. And we divide by whatever is in front of x. So since that is a regular positive 2, in front of x, we're going to divide by a regular positive 2 to both sides. Those 2's will divide out. Your x is now isolated. You will type in 1 divided by 2 into your Desmos. If you get a decimal, which you will on this one, remember to tap that fraction button and change it back. Sometimes it reduces the fraction, sometimes it does not. On this one, 1/2 was your final answer for the first factor. Then we need to go back to the second factor, x plus 5, set that equal to 0, and then we're going to solve for x. This one only has one value to remove, which is a +5. Opposite of a +5 is -5 to both sides. Zero out those opposites. Drop down your x and simplify that right side. 0 minus 5 is -5. So these numbers that we are solving for x, these are going to be our solutions, so that if we were to go and graph these, we would see that these numbers is where that quadratic, that U shape, is actually crossing the x-axis like it did up here. We're just doing it by hand because we're not always given a picture to do so. So you're going to do the same for number 3 and for number 4, because you can see that 3 and 4 are already set equal to 0 and they are already in factored form. So if you want to pause and try on your own, you do have multiple choice, and then you can unpause and come back and check. But I'm going to go ahead and do the same steps where I'm going to take each factor, set it equal to 0, and solve for x. Opposite of -6 is +6 to both sides. Opposite 0 out. X is isolated. 0 plus 6 is 6. Round 2 with the second parentheses, the second factor. Set it equal to 0. Solve for x. I have a -6 again, so its opposite is still a +6. Opposite 0 out. Your x is now isolated. 0 plus 6 is still 6. So you can see that this is a special case because both factors are the same. And so when you solve for x, you get the same answer. And so when you're looking at your multiple choice here, the first thing that you want to pay attention to is, are these braces or are these parentheses? In other words, are these a list of numbers or are these a list of ordered pairs? And so they have the curly braces, which means they're just listing those x numbers. And you can see that there's not an option that says 6, 6. And that's because 6 is repeating. And so if you happen to get the same number, you don't have to write it more than once. We learned that when we did domain and range. So our final answer on this one is going to be A. It only is going to cross at 6. So if you were to graph this, you would actually see a parabola that when it's touching the x-axis, it only touches once, but it's touching at a +6. Okay, you will do the same thing for number 4. Again, this would be a good time for you to pause, try it on your own, and then come back to it. Take each factor, set it equal to 0, solve for x, move your -4 by doing the opposite, opposite 0 out, Drop down your 3x. 0 plus 4 is 4. X is not alone yet. Put your multiplication symbol to remind you to do the opposite of multiplication, which is to divide by that coefficient in front, 3, to both sides. Divide out your 3's. X equals, go to your Desmos, do 4 divided by 3. You get decimal, hit that fraction button, and you get 4 over 3 back. So you can kind of see this one as a maybe. Let's go to that second factor, or that second parentheses. Set that equal to 0. Start solving for x. Opposite of a +1 is a -1 to both sides. Opposite 0 out. X drops down. 0 minus 1 is -1. So yes, you can see this was our final answer. All right, now the last two, 5 and 6 here, they are set equal to 0. So step 1 is good. And remember, your list of steps are right here. Step 2, though, says to factor, and you can tell these are not factored because they don't have that parentheses. So when it's not factored, that's when you have to do your snowflake method yourself and then continue on the process. So let's go ahead and do 5. And make sure I have all my coefficients. So that front coefficient that's hidden right there, it's not shown. Remember, when we do our snowflake method, you have your star helper. And the first thing that your star helper says to do is to find your GCF. And so to find your GCF, you're going to type it into Desmos with your 3 coefficients, starting from the left 1, -10, and 21. You will type that in to Desmos and see what your GCF becomes. So GCF. And then you're going to hit your parentheses. You're going to do 1, comma, -10, comma, 21. Close your parentheses. And you can see that your GCF is a 1, which is nice. Because when your GCF is a 1, that means when we go to the next step, which is when we divide out the GCF, we don't have as much work to do, because anything divided by 1 is itself. You can start typing it in, 1 divided by 1, -10 divided by 1, 21 divided by 1, but you're going to get the same numbers. So it's going to stay the same, and that helps us with our A, our B, and our C. So on this one, our A is a +1, B is -10, C is 21. Now we can set up our snowflake with our air condition up top. And so we're going to do our A times C. On this one, our A is 1, our C is 21. 1 times 21 is 21. We're going to do our B on bottom. Our B is -10. And then remember, we have our pictures of our axes. So we're going to take the A number 1 and put an X next to it and do the same thing. Our A number is 1, put an X next to it. And now we need to fill in those last 2 spots by doing our cross puzzle, where we need 2 numbers that multiply to 21 but add to -10. And so remember, if you don't know your times tables, you take your target 21, you start by dividing by 1, and whatever number you get, that's its partner. So 1 and 21 are the first set of options. Okay, then I'm going to go back and I'm going to test. Does 1 plus 21 equal -10? Definitely not. Okay, so then I'm going to go back here, put 2, that's a decimal, 3 and 7. So I'm going to write that down, 3 and 7. Now I'm going to see if they add to that bottom number, -10. So 3 plus 7 is not a -10, it is a +10. So we're close, but we do need to do a change. So this is where you need to be careful with your signs. I still need the top number to be a positive 21. So if you only do one negative, then when you type that in, negative 3 times 7 is no longer a positive 21. The only way to keep a positive number is to have double positives, which we started with, 3 and 7, or make the change to double negatives. The two negatives will keep it a positive 21, and now negative 3 plus negative 7 is a negative 10 like we wanted. So we need double negatives on this one. So negative 3 and negative 7. All right, from there, we need to check and reduce our numbers here on the left and numbers on the right. And remember, the trick is if you already have a 1, it's more than likely not going to be reduced. But I'm going to go ahead and type it in just to kind of go over our steps with factoring if you're still having trouble with that snowflake method. I'm only going to type in the numbers 1 over 3 and 1 over 7. I'm not typing in those minus signs because I already know I'm going to keep those minus signs. We get decimals, so we tap on the fraction buttons, and you can see that the numbers did not change. 1 over 3 stayed the same, and 1 over 7 stayed the same. So that means we're going to keep it as is. And so when we write them as factors, it's going to be 1x minus 3 and 1x minus 7. You can also choose to not write the ones and do x minus 3, x minus 7. So this is where we stopped on the last test. This would be the factored form. What we're doing now with today's notes is continuing on. And remember, from the beginning, it was set equal to 0. So now this is our new problem. And we take each of those factors, we set them equal to 0, and then we keep solving for x. So we're going to do the opposite of minus 3 to both sides. Opposite 0 out. Your x will drop down, isolated now, and 0 plus 3 is 3. Same thing for your second factor. Set that equal to 0. Start solving for x. Opposite of minus 7 plus 7, both sides. Opposites will 0 out. Your x is isolated. 0 plus 7 is 7. So this one has two solutions at 3 and at 7. Okay, now I want you to pause and try your own and do the full thing for number 6. Practicing that snowflake method because it's not going to go away. All right, running it back real quick here because I want to make sure that you have done all your proper steps. When you typed that in, you should have got a GCF of 1 so that when you divided by 1, it stayed the same. So that your A is a 1, your B is 10, and your C is 25. So then you would have set up your snowflake with the top number A times C as 25, your bottom number B as 10, your X, your A as 1 with an X on both sides. Picked two numbers that multiply to 25 that added to 10, which would have been 2 positive 5s. You would have then reduced your fractions, type those in, and you would see that they would not have changed. So your factors would have been 1x plus 5 and 1x plus 5, or choosing to not write the ones, which would actually make it easier later on, would be x plus 5, x plus 5. That would now be set equal to 0, and this would be our new problem to keep solving. You would take each of those factors, x plus 5, and set it equal to 0 and start solving for x by doing the opposite of plus 5 to both sides. opposites zeroing out, x is isolated. 0 minus 5 is negative 5. And then you would have repeated the steps on the second factor, but hopefully you realized that those were the same, and so you didn't have to do double work, that you only had one solution for this, which was at negative 5. Now, these do take a lot of work and a lot of patience, but it's definitely something that you can do because you have been solving for x for a long time, and we've really kind of mastered the snowflake method now. So there's only one last round that we need to do to make sure that you are completely successful. And we're going to look at number 7, 8, and 9, and we're going to do one last method. Okay, so if you look at number 7, remember that step number 1 says to make sure that it's set equal to 0. It is. Step 2 says to factor, and it is factored. You can tell because it has that parentheses. So we're going to do step number 3, where we're going to take each of these factors, and a factor has to have an x with it. So that 3x in front, that is a factor. And we're going to set it equal to 0. And we're going to take that second factor, set it equal to 0, and solve for x. So you can do your steps that you learned about isolating the variables, doing the opposites, and getting your x numbers. Or we can do one last method, which is if your equation is already set equal to 0, that means you can actually graph it into Desmos, and you're only going to graph the part in front of the equals 0. So this is what I wanted to show you, that if you are able to do the graphing method, then do it. So we're going to type in 3x parentheses x plus 2 into Desmos. You can see that U-shaped graph. We got our quadratic. And then remember, we're looking for roots, zeros, x-intercept solutions. So all we have to do is find the x-axis. Remember that if you don't know which one is your x and your y, Desmos can tell you. You hit that wrench at the top, and it tells you to label x, and then it tells you to label y. And then you tap back on your graph, and you can see that the x and y is now labeled. And so your x-axis is this one. You can tap on it right away, and it gives you those x-intercepts. It gives you those roots, those zeros, and those solutions. So we have -2, 0, and 0, 0 as our options. So -2, 0, and 0, 0 was our solutions, which you could see if you had done the work yourself, -2 and 0 were already done. Or you can write them as braces with just the x number -2 and the x number 0. So that one's a lot faster to do, but you have to be able to get it equal to 0. So if you look at 8 and 9, they are not set equal to 0. And so in order to use that graphing method in Desmos, we do have to do a little bit of work ourselves. Nothing too crazy though. So you're going to find your equal sign. And remember, our goal is to make this equal to 0. So all we're going to do is opposites. Opposites make zeros. So you can see that we have on the right side a positive 126. So the opposite is a negative 126. We also have a minus 7x. So its opposite will be positive 7x. But remember with equations, what you do to one side, you do to both sides. So I have to do a minus 126 and a plus 7x to both sides. But on that right side, these opposites, they're going to 0 out. And so now we do have an equation set equal to 0. And all we need to do is fix our front side. So I'm going to drop down that 3x squared, because when I'm looking at these terms here, we got to be able to combine the like terms. And there's only one x squared, so it's going to stay itself and not change. But there are some like terms here that we can combine. There's these x's right here. So we're going to combine that -10x and positive 7x. And you can type that into Desmos if you need help with your positive and negative numbers. Just remember that you can only type in the coefficients. Negative 10 plus 7, that gives us a negative 3. And we're going to keep that x. And then that last number, minus 126, it's a constant. It doesn't have a letter with it, and it's the only one of its kind, so we're going to drop it down. So now that it's set equal to 0, all we're going to do is type this into Desmos, see where it crosses the x-axis, and save us the rest of the work from having to do the snowflake method and then keep solving for x that way. Because technically, we've already done some algebra by setting it equal to 0 ourselves. So let's go ahead and type in 3x squared minus 3x. So we do 3x squared minus 3x minus 126. So it doesn't look like the U shape. You can zoom out if you want and if you don't trust the graph, but it is a U shape, but you really don't need to zoom out. So I'm gonna hit that house button and go back to normal. Because remember, we want that x-axis as our solutions. And we already labeled the x-axis from the previous problem, so I'm just gonna tap on where it crosses the x, and I could see negative 6, 0 and 7, 0 are our final solutions. So I'm gonna write them as ordered pairs, negative 6, 0 and 7, 0. And then I'm gonna practice writing it in that second form, where all I do is just take the x number negative 6 and the x number 7 and make a list of x values. So it only crosses the graph, and double checking, it only crosses the graph at negative 6 and 7. All right, one last one with me, and then you will switch to your daily grade, where you can choose whichever method that you like best. If you want to solve them all by hand, or if you want to set them equal to 0 and let Desmos do the rest, that part will be up to you. So we're just going to practice one more time how to make something equal 0 if you want to use the Desmos method. So remember, think of 0 as the word opposite. The only way to make zeros is to do the opposite. So on that right side, I have a positive 2r squared. So the opposite of a positive would be a negative 2r squared. What you do to one side, you do to the other side. That right side, those opposites, they will zero out, which is what we want to happen. So we do have something equaling 0. And now we're going to zoom and focus on that first side where I have a negative 2r and a negative 2r squared. If you need to rewrite it to see it better sideways instead of vertically, you're welcome to do so. You do not have to. But if that helps you to see that an r and an r squared are not like terms, it's super helpful because they are not like terms, so we can't do anything with them. And so we are going to just finalize it. We do need to make sure that our quadratics are in proper order, highest to lowest exponent, and we did practice that before. So your highest exponent will be a 2. That exponent belongs to the r belongs to the big 2, and that big 2 belongs to the minus. So that negative 2r squared is going to go in the front. And then that second term, minus 2r, will go in back. Now, a lot of students don't like to use different letters other than x's, so you are welcome to use an x instead. But remember, once you get it set equal to 0, you only use the part in front and type that into Desmos. So we're going to type in negative 2x squared minus 2x. So negative 2x squared minus 2x. You can see our quadratic, our U shape. And then there's 3 points, but remember, you only want the point on the x-axis. So we have negative 1, 0, and 0, 0 as our final solutions. So negative 1, 0, and 0, 0 are our x-intercepts. And then we're going to practice our braces where we take just the x numbers, negative 1 and 0, and list them from left to right.